Okay, so in this example, right, I'm going to show you the idea of simultaneous quadratic inequality. So in example 1 and example 2, we explore something like single quadratic inequality. So right now we got simultaneous. That means you got two inequality. So basically, you are going to proceed in the same idea. But because you got two inequality, you will end up having two sets of answers. You actually need to know how to combine the two sets of answers. So I'm going to show you here. So if you look at this question, so if you look at this question, so there is a bracket in the middle. So that means this quadratic function is between these two values. Okay, so I'm going to approach it in this way. So I'm going to do my basic expansion. So you do your basic expansion, algebra expansion. It will lead you to get something like this. Okay, so do your normal algebra expansion. So how are we going to get our two simultaneous uh, linear inequality? So the first one will be here. So this will be my first inequality. And then this will be my second inequality. So these are the two simultaneous. So it's something like equation 1, equation 2. So equation 1, equation 2, right? You perform like single inequality. So you recap the steps that you have encountered in example 1. So I'm going to redo the steps. So I'm going to shift all the function. So I'm going to shift all the function in such a way that I can factorize. So that is the first step. So after factorizing, don't forget you are looking for the portion of the graph. In this case, right, I'm looking for the portion of the graph that is below the x-axis. So I will draw the function. Okay, as I mentioned before, the intercept, you mentor from the bracket. If you mentor from the bracket, you will get 1 and 6. And we are interested in the portion that is below the x-axis. So this is the portion that I'm interested in. And it corresponds, look at the x value. It corresponds to 1 to 6. So this is the portion that is below the x-axis. So that I solve my first inequality. So I'm going to go to the next one. So the next one, okay, when I try to do the next one, if you look right, this is a negative. So by right, it is a set phase graph. So usually I do not favor doing a set phase graph. So what I'm going to do is I'm going to divide -1 on both sides. Okay, I'm going to divide by -1 on both sides. So you must remember to reverse the sign. So I prefer to deal with positive x squared. So in a way, I prefer to deal with a small graph rather than a set phase graph. So that's what I can do. I divide by a -1, but I remember to reverse the sign. So then I do my factorization as per normal. And I'm looking for the portion of the graph that is above the x-axis. So it's a small graph already because you already successfully changed the set phase graph to a small graph. So mental the x-intercept again, and you are looking for the graph, the portion that is above the x-axis. So for the portion that is above the x-axis, you observe the x value. The x value is less than 2, you observe this portion, all the x value are going to be greater than 4. So this will be your 2 answers. So this is your first answer. This is your second answer. So you need to combine them. You need to find a common set of value that is applicable to both of them. So how am I going to combine? So I'm going to combine 1 and 2 on a number line. So if you're going to be combining, you make sure your number line has all the necessary value. So I will need 5, 6. So if I look at the first number line, it will be 1, 2, 6. So if I look at the second number line, less than 2 and greater than 4. So the final answer will come from the part where you will see a double line. So that means, right, that is a common region that's applicable to both. So for this common region, it will be 1 less than, it will be between 1 to 2. For this common region, it will be 4 to 6. So it's actually very lengthy when you do simultaneous quadratic inequality. So you will have 2 sets of answers and you will need to combine the 2 sets of answers. So if there is any single mistake, any tiny mistake, right? Okay, everything else is actually affected. Okay, so this one needs a bit of practice. So it's called simultaneous quadratic inequality. Okay, in example 4, we're going to explore the idea of backwards. So in a way, right, they actually tell you that, so in a way, they tell you that, they tell you the answers. So this is so what you can do is something like this. So they gave you a quadratic inequality. And from here, we know that it is a part that is below the x-axis. And because of the answers, I kind of understood that from here, I understood that it will be a -4, -2 and 4. And it will be this region. Okay, so this is the understanding of the question. So right now, I got to find my A and B. So how am I going to find my A and B, right? So from this idea, right, I know that these two are the x-intercept. So -2, x equal to -2, and x equal to 4 are the x-intercept. And where does the x-intercept come from? So if you recall your previous step, usually you get your x-intercept by mental out the bracket. So actually this one will come from x plus 2. So x equal to -2 came from a x plus 2 equal to 0. X equal to 4 came from a x minus 4 equal to 0. Okay, so this is like a thinking process. You do not need to show. You actually don't need to show. So this is a thinking process. So with this thinking process, I actually came up with 2 brackets. So I'm able to come out with 2 brackets. So I know that I'm exploring the portion that is below the x-axis. So then I do my normal expansion. Okay, you can compare. So this is what you work it out. You work it out based on your understanding of the x-intercept. And then you are going to compare with the original question. So if you compare with the original question, you will realize that A is equal to -2 B is equal to 8. Okay, so alternatively, some people will do this. Alternatively, some people, after they got the two brackets, they do the normal expansion. They do this, and then they compare with the original question. So they compare with the original question. They still get the same set of answers. So you can compare with the original question. Okay. It doesn't change your answer. So it depends on which one you want to compare with. Okay, so that is the idea. So you gotta work backwards. You work backwards with the x-intercept in mind. If you don't have the x-intercept in mind, you wouldn't be able to get the bracket and your function cannot appear. Okay, so the next one here, okay, I also got a quadratic function. Let's explore the quadratic function. Again, it's a small function. And we are looking at the portion that is above the x-axis. So in a way, right, I'm looking at the portion above the x-axis. And I get two sets of answers. So that means I get two sets of answers. So this will be one set of answers. I gotten this set of answers and this set of answers. So this set of answers correspond to this portion, and this set of answers correspond to this. So that's the interpretation. So when they say that this quadratic inequality is satisfied by this, that means they are telling you the answers. From the answers, again, we're going to work backwards. So what will be my thinking process? My thinking process will be, I'm going to think of the -2 and 3 as the x-intercept. The x-intercept came from the bracket. So the bracket will be x plus 2. The bracket will be x minus 3. So again, this is the thinking process. The thinking process will lead you to come up with two brackets. Okay, so for this question is a little bit tricky. So right now I got the two brackets already, but then you must realize the coefficient is actually a 2. So if based on my two brackets alone, I will not be able to get 2x squared. So if I use my two brackets alone, I cannot get a 2x squared. Just based on these two brackets, I will be getting x squared. So I got to introduce a 2. So this is the function that I came up with. So with the thinking process of the x-intercept, I came up with this, and I'm going to do my usual expansion. So I'm going to do my usual expansion. I'm going to expand out. Okay, so after you expand out, you can compare with this. So after you expand out, you can compare with this. So if you compare, you will be able to get A equal to -12. Okay, B is equal to 2. So similarly, you can choose to compare in this way. So, okay, so from here, okay, so what I can do is, right, if I want to compare with the original format, so I'm going to compare with the original format. So you compare 1 and 2. But I'm comparing with the original expression. So if I compare with the original expression, I also gotten the same answer. So it's up to you. Would you want to compare with the original expression, or you compare with this function? So whatever is it, when you need to work backwards, you got to target the x-intercept, because the x-intercept came from brackets. And when you manage to obtain 2 brackets, that's where you can create a quadratic function. So this is the main thing about quadratic inequality. Moving forward, when you solve an inequality, you are looking for the portion that is above or below the graph. When you are working backwards, you target the x-intercept to come up with the brackets to create a quadratic function.